Hello, welcome to this video on the quadratic nth term. I'm going to go through a bunch of the exam questions that have come up in the last 4 years, go through every single one and explain it to you in a method that I prefer, that I think it relies less on memory and it kind of makes more mathematical sense, which will make it easier for you to actually remember it in the exam and get those full marks. But before we get started, I just want to let you guys know, if you look at the pinned comment or the link in the description, I have some spaces in my group classes for GCSE and A-level maths tuition. So if you're interested, you can book your free one-on-one trial, again with the link in the pinned comment or in the description. But let's get into the first question. So a quadratic sequence, we need to find the nth term. It's a super common question, comes up most years. The first thing, all you need to do, and I'm going to write out the sequence just one more time to make it a bit clearer, is you start it the same way as you do with the linear sequence by just finding out what the common difference is. Now what you're going to notice is the common difference is not the same each time. In fact, it changes. So it's going up by, well, you can see it's going up by 4 each time. Okay. Now when we think of the term quadratic, I'm hoping that you're thinking of an equation that looks like this. So as an example, you might have 2x squared plus 3x plus 4 or something like that. That's what a quadratic equation looks like. That means we expect the quadratic sequence to have an equation that looks like this. So it should have an x squared and it should, well, actually just an x squared. It doesn't have to have the x, it doesn't have to have the c. So when we're doing this, we're going to write out that our equation is going to look something like this. Now the only thing it has to have is n squared. It might have a bn, it might have a c as well. Now, the next thing you're going to do is you're going to find the second difference of this. So you're going to work out what the difference is going up by in each time. Now here's the only bit you need to remember. The only bit you need to remember from this whole method, which is that a is always half of that common difference all the time. So if it was -6, half it is -3, whatever. We're going to go through some more examples anyway. So a is always going to equal 2 in this case. It's going to be half of that common difference. So that means we now know our equation looks like this. 2n squared plus bn plus c. But how do we find bn and c? Well, to do that, we need to think about what n actually means. So what I'm going to do is I'm going to drag this down to give us a little bit more space. So I'm just going to move this about a bit, drag this down, and then we can have a little bit more space to talk about it. And think about what n represents. N represents what position you're in the sequence. So for example, n is 1 gives us the first term of the sequence. It should give us 5. N is 2 should give us the second term of the sequence, which is 11. N is 3 should give us the third term of the sequence, which is 21, and so on. So how can we use that to help us? Well, it's actually exactly what I just said. When n equals 1, we should get an answer of 5. So when n equals 1, we should get 5. So let's actually sub that in. We get 2, 1 squared plus b times 1 plus c equals 5. So if we just expand that quickly, spoilers, we get 2 plus b plus c equals 5, which gives us b plus c equals 3. And that's our first equation. We're going to do the same thing for n equals 2. I'm going to explain why I picked those two numbers in a second. It will make a bit more sense. So again, we're going to sub it in. We get 2 times 2 squared plus b times 2 plus c. And what should that equal? It should equal 11, the second term in the sequence. So 2 squared is 4 times 2 gives me 8 plus 2b plus c equals 11. So we get 2b plus c equals 3. Now, I'm going to show you why we picked those two values, because we can actually solve that now. It's a simultaneous equation. Now I know you're thinking, simultaneous equation, that sounds difficult, but take a look at how quick we can solve these two equations. I'm just going to write them on top of each other for you. So, I've written them on top of each other. Look how easy this is to solve. The number in front of c is the same already in the equation. So if I subtract these two equations, I get b equals 0. I've already worked out what b is. And now I know that b is 0, I can just sub that straight back in, and I can get 0 plus c equals 3, so c is equal to 3. We solved that in about 10 seconds. That's the power of this method. It's very, very quick, but at the same time, it's based on the maths you already know. You're not really learning anything new. So it means our answer is 2n squared. B is 0, so that's 0, plus 3. So 2n squared plus 3 for that answer. So why did I pick n is 1 and n equals 2? Well, if you have a look for a second, the reason why this was so quick to solve is because this 2b and this b are the exact, they're only one away. When we subtract them, we're just left with b. That's because I picked n is 2 and n is 1. If you always pick n is 1 and n is 2, you can solve it this quickly every single time. And I mean every single time, bar none. You always solve it that quickly, which is really, really nice. Now, of course, you should check your answer by subbing in different values. So, as an example, if I sub in n is 1, I should get 5. So 1 squared is 1, times 2 is 2, plus 3 is 5. If I sub in n is 2, I should get 11. 2 squared is 4, times 2 is 8, plus 3 is 11. So I have got the right answer. I'm going to give you another one. I'm going to do this one, and I want you guys to do the one after this, okay? So I'm going to let you pause the video in a second. If you really feel confident, you can pause it now, but I'm going to talk through this one immediately. So when I write out the sequence, what was the first thing I did? I found the difference between these. So that goes up by 11, that goes up by 17, that goes up by 23, that goes up by 29. And then we find the common difference between that. So that's 6, and it should be the same. If it's not the same, it means it's not a quadratic sequence. So perhaps you've done something wrong slightly. Why was that important? Can you remember? If you remember, we have an squared plus bn plus c. The a is always half of this common difference. So straight away we know a is equal to 3. Super, super useful. So our equation so far is 3n squared plus bn plus c. Now what did we do next? So that's the first major step. What was the second major step? The simultaneous equation. So what we did, if you remember, we picked n is 1 and n is 2. Because if you pick 1 and 2, it makes the simultaneous equation really, really easy to solve. So when n equals 1, we should get 10, because the first term is 10. So let's do that. N equals 1, we should get 3, 1 squared plus b1 plus c equals 10. So that's 3 plus b plus c equals 10. So b plus c equals 7. That's my first equation. Do the same thing with n equals 2. If n equals 2, we should get 21 because that's the second term in the sequence. So if we sub that into, again, back into our equation we've gotten so far, squared plus b2 plus c, then 2 squared is 4 times 3 is 12, 2b plus c, in fact I should write that equals 21, equals 21, so 2b plus c equals 21 minus 12 is 9. Now it's just solving it. How do we solve it? We write them on top of each other, and it's a super, 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 super easy and simple and quick equation to solve. We just always subtract them, and we always get b equals something. We get b equals 2 in this case. Then you sub it back into that bottom equation, you get 2 plus c equals 7, you get c equals 5. How quick is that? It's always that quick as well. It doesn't matter what question you get, you will always get something that fast to solve, which is really, really nice. So our final equation, remember we know that b is equal to 2 now, and we have c is equal to 5, is this. Our final answer is 3n squared plus 2n plus 5. Done. If you'd like, you can check by just subbing in n equals 1 and n equals 2, just to see if you get that same sequence. Now, here's one I want you guys to do. So please do pause the video. Feel free to look back earlier in the video so you get a full example if you've forgotten how to do part of it. But again, through doing this, you'll actually kind of improve faster. Okay, that should be enough time. Let's go through it. So again, we write out that expression. What do we do next? You find the difference. That's going up by 1. That's going up by 3. That's going up by 5. By the way, it can also be a negative number. It does not have to be a positive number. The difference can be negative. That goes up by plus 2. That goes up by plus 2. That goes up by plus 2. Why do we do that? Because a, the number in front of n squared, is always half of that difference, which is 1. It could also be a fraction. Okay? It can be. There's no reason why not. So that means our equation so far is n squared plus bn plus c. What do we do next? We sub in n equals 1 and n equals 2 so that we can solve it. So when n equals 1, what do we get? We get 1 squared plus b times 1 plus c equals negative 1. So we get 1 plus b plus c equals negative 1. So that's b plus c equals negative 2. Okay, because you subtract 1 from both sides. Then we do the same thing with n equals 2. When n equals 2, we should get 2 squared plus b times 2 plus c equals 0. Again, let's expand it. So we have 2 squared, which is 4, plus 2 times b is 2b, plus c equals 0. So we get 2b plus c equals negative 4 because we subtract 4 from both sides. Then all we do is write them on top of each other, subtract them, done. Super nice. So, oh man, spoilers, I need to remove this question. So, let's put them on top of each other and solve it. Again, hopefully you're just checking your work as you went along. Now we subtract it. So 2b minus b is b, c minus c is nothing. Minus 4 minus minus 2, be careful with that, is minus 2. Subbing that back into here, we have minus 2 plus c equals minus 2. Add 2 to both sides, c is 0. So those are our two values. So let's write this out. We have n squared minus 2n plus 0. So hopefully you got that one right, but if not, I'm going to give you another chance. This is the last exam question that's come up. So again, we've done the last 4 or 5 years of exam questions. Have a go at this one, see if you can get it right. Okay, let's start going through this exam question. Again, what does it go up by each time? That's the first step in every single question. So that goes up by 6, that goes up by 10, then 14, that should be 18 and 22. Then we find the next difference. So as you can see, it's going up by 4 each time, which means what's a? A should be 4 divided by 2, which is 2. So that gives us, so far, 2n squared plus bn plus c. And now we just need to solve the simultaneous equation by subbing in n equals 1 and n equals 2. So when n equals 1, we get 2, 1 squared plus b 1 plus c should equal negative 1, just from the question. 1 squared is 1, times 2 is 2. So 2 plus b plus c equals negative 1. Minus 2 from both sides, we get b plus c is negative 3. That's our first equation. Then when n equals 2, we should get 5, but before that we get 2 squared plus b times 2 plus c equals 5. 2 squared is 4, times 2 should be 8, plus 2b plus c equals 5. Subtract 8 from both sides, we get 2b plus c equals negative 3. And now all we have to do is solve it by putting them on top of each other and subtracting as usual. So that gives us 2b plus c equals negative 3, and on the bottom it's b plus c equals negative 3. Cool. Subtracting those two equations gives us b equals minus 3 minus minus 3 is 0, of course. And subbing that back in, we get 0 plus c equals negative 3. So that means c is equal to negative 3. So our final answer is 2n squared. There's no b, okay, and then minus 3. So again, you can get b or c being 0. You will never get a being 0, because there's nothing you can divide by 2 to get 0 except 0. So yeah, hopefully that makes a lot more sense. Once again, if you're interested in booking that one-on-one kind of initial trial session with me, then do see the link in the pinned comment or the description, but I'll see you in the next one.